Okay, let's start on this. Right, it's just you, I think it's just you because the other two of them haven't gotten their papers back yet. And one of them is having another tuition. So it's just you, dude. Hmm. Okay, come tell me what you need. Huh? The first MCQ all the way to 11 is okay, ah? Whoa, wait. What's the correct answer for question 2? Why is it 5 km? Okay, good. Why is it non-zero? Velocity has direction. So you change the direction of velocity, v change to v here. Right? There's a change in velocity. There's a change in velocity means there's acceleration. What's the definition of acceleration? Yeah. So now the question is this: why did you get tricked? Correct. So, but it's not like I never gone through before. I thought I gone through before. So you have to be extra. Who's that? Oh, hello. Who's that? Oh, Yi you made it. Okay, can. Sorry, I know you don't have your paper yet, so I'm just gonna go through this one now. Okay. Uh, so you're saying that you understand all these, is it? Question 3, you understand? Okay. Question 4. So weight is a gravitational force experienced by a body, right? So even though the first part looks very correct, it's like, oh, mass refers to amount of matter in body. Yes. But the second part of the statement doesn't sound quite right. Because weight is what? Weight is G force acting on body, right? So you cannot choose C because you feel that the front part of the answer is the closest to it. You have to look at the whole thing, right? The whole statement. So if C looks a bit wonky, then you look at D because obviously A and B is wrong, right? I mean, we can tell that A and B is wrong. So if we look at D, mass can be measured using a beam balance and weight can be measured using a spring balance. D is absolutely correct because that's what it is, right? That's how you measure mass and how you measure weight. Okay? Question 5. Whoa, this one's a hard question. So they want you to talk about what's the action reaction pair to force F2. Okay? Right? Okay. So F2 is the force exerted on the ball by the racket. Yeah. So B is your answer. Right? By ball on racket in the upward direction. So it's a frictional force. It's a fractional force because the F1 is the normal force. You understand this? Okay, this one is a higher level question. Okay, it is a higher level question, but you know, at least we can cut it down to by ball on racket, right? So I think you cross out A and C here, which is good. But I think wait, do you get this correct or not? No. So you chose normal contact force. But normal contact force has to be perpendicular to the surface. That's why it's called normal, right? Normal means perpendicular. So the surface is here. F1 must be the normal contact force. So F2 is the friction, right? The ping pong bat is made of rubber. You need the friction to cut the ball so that the ball will spin. I mean, that's the whole idea of what ping pong is all about. But okay, fine, right? Never mind. We learn and we move on. Okay, next one. Number 6. Are you okay with number 6? Number 6, okay. But why? What is the force exerted by Z on Y? Like, if I ask you to draw an arrow, how would you draw this arrow? By Z on Y. You see, right? There's a difference in knowing what the answer is and understanding the concept behind it. So you have to really bite the bullet. It's going to be really difficult and uncomfortable to understand the concept because it's like, oh, I just want to get this over and done with. Oh my God. But then that means that you're just ignoring the concept, right? So the force exerted by, and as I'm going through, I hope you're doing extra markings on this. That means you're drawing the corrections and all that, right? On Y, it's literally this force here. Like there's a normal contact force, right? By Z on Y. Do you see how all these questions here, you see, question, question 5, question 6, all right? Question 5, question 6. These two questions are force questions, and straight up they whack you with by and on. And when I was teaching forces, I don't know whether I got revised forces, but when I do teach forces, I always tell my students I emphasize a lot on by and on because any force must be always be described as by and on. So by Z on Y is pointing upwards like that. So if you want to learn how to do like how to figure out what's a force, you have to look at Y and X and then treat them like one object like this. And then this is the normal contact force acting on Y. Right? This is the normal contact force by Z on Y. And the reason why it's equals to, right, X plus Y is 10 plus 25 is because the weight of X is 10 and the weight of Y is 25. So you have a combined weight of 35. So your combined weight of X and Y, now I fuse the two of them together, X plus Y, right? You can see it as a single object where the combined weight is 35 and the end force is also 35 to balance this X plus Y on top of Z. Okay, anyway, that's for question 6. Question 7. Okay, I'll go through this one. This question is with regards to what? What's the concept behind this question? Huh? What are you talking about? What? No, what's the chapter behind this thing here? Moments. So moments, you got to know where the pivot is, right? The pivot is here. Moments, you need to know the perpendicular distance from the force. So there's how many forces acting on this fishing rod. Okay, fishing rod. Okay, hang on. Okay, let's see. Okay, so there is a hand supporting, which is basically the pivot. So technically there's a force by the hand, but we're going to ignore that for now because the force acts through the pivot. So there's no moments by this hand here. Right? Wherever I'm pointing, right? You see my program, I'm pointing here. There's no moments by this hand here. Okay? But there's moments by the fish, and there's moments by this hand pressing down on the rod. Okay? Pressing down on the rod. Like this. Okay? There's these two forces. Okay. So now the next thing is to understand that, right? The next thing is to understand that, right? Like there's a fish pulling it downwards here. What kind of moments is this? What kind of moments is the fish giving? Good. What kind of moments is the hand here giving? Okay. Then the hand at the pivot, no moments. But one thing that I'm a bit concerned about is where's the weight of the fishing rod? You know, that usually we will have the weight of the fishing rod as well. Like we will add in the weight of the fishing rod like this. You know what I'm saying? But did they say anything about the weight of the fishing rod? Did they mention how heavy the fishing rod is? Did they mention where's the center of gravity of the fishing rod? Basically, no, right? Yeah, it don't have. So that's the problem. Okay, I mean that's not the problem. As in like, so since they never mentioned anything about the fishing rod, okay, you firstly you understand that if you're very good at this kind of moments question, you realize that oh yeah, they didn't tell me anything about the fishing rod. So then you say you would think you should be thinking that this question is slightly flawed because there's no way of fishing rod. But okay, fine. You don't give me the information. I'm not gonna take the info. I'm not gonna take. I'm not gonna add that in. Right. So there's only two moments. Moments by right. Moments by the fish and moments by the hand. Right. Right now, maintain equilibrium. So anti-clockwise moments equals to clockwise moments. Okay. All right. So the big thing to remember is this. Right. If I ask you define moments, can you calculate moments for me? Moments equals to what? Force times perpendicular distance from line of action to pivot. Okay? Many times over the years, a lot of students always first instinct, walao we have to go and memorize so many things. What's all this about? Hey, you are not doing bio, it's already very heng already, okay? Moments equals to force times perpendicular distance from line of action to pivot. This is your line of action. This is your pivot. You need this distance. That is the distance that you need. Okay, for the fish. So conveniently, it's 12 times 1.6. Okay, so ACW equals to CW 12 times 1.6. Then let's look at the hand. Now the hand, very strangely, the hand is not acting vertically downwards. It's acting at an angle. So you cannot take 0.4 because the line of action of this hand is like that. Sorry. Right, the line of action of this hand is going at an angle like this. Okay? You understand that? Okay, but here's the thing, Again, this question is flawed because whoever said this question intentionally tried to trick the students, not realizing that they probably missed out an important point, is that you should have indicated there's perpendicular here. That's unfair. This is unfair. Because if you tell me that this diagram is not to scale, how am I supposed to see that this force here is actually perpendicular to the fishing rod? But now that I'm telling you that it is, because otherwise there's absolutely no way for you to solve this question, right? Now that you know that it is perpendicular to the rod, it means that the force times 0.5 is the clockwise moments. Then you use this equation, find force. Okay or not? But it's unfair. It's unfair because the teacher never indicate it's a perpendicular. Because if he put perpendicular here, right, he's scared. Too obvious. It's too obvious for the students already. Let me try to make it less obvious. Let me not draw the perpendicular sign here. See whether students will take 0.4. But then to those students who like a bit more like they are aware one, right? Walao, how am I supposed to know what angle is it? Right? So what am I supposed to do? So the thing is this, dude. There's absolutely no way for us to use the 0.4 because the force is not vertical. The best chance is to just use 0.5. So we just take 0.5 lah. Okay so far? Okay, so force is that one. Okay, next one. Question 8 ah. Do I need to do 8? Sorry, I don't understand what you're saying. Huh? Yeah, cannot be 4, so it's either 1, 2, or 3 lah, right? So position 1 is like in the middle of the D, right? But there's an extra mass here, so it cannot be D. It cannot be 1, right? Position 3 is... It's a close call between 2 and 3 lah. Yeah. It's a close call between 2 and 3. That's not very fair question also lah. Whoever said this question also a bit like never think carefully also. Yeah. But okay lah, it can't be 3 lah. 3 looks like it's too low already. Because it's a uniform wooden block, right? That means that the thickness of this wooden block, right, is even. Okay? So if you put position 3, right, you see you have a lot of mass on the top and you have very little mass at the bottom. Right? It's not possible that the center of gravity is at position 3. So it's more likely to be like here, like half like that. Right? A bit of mass on top, a bit of mass at the bottom. So position 2 is the best answer. So B is your answer. Okay? Question 8. This one, number 9. Do you need number 9? Number 9 is which of the basins are experiencing the same atmospheric pressure? Okay, so these buggers also a bit tricky. They purposely go and draw the dotted lines for this one. This one they completely never go and draw this one. Okay, you do you understand that you can sense that the teacher is intentionally trying to make the student make mistakes? Yeah, it is because nothing in life is straightforward. Okay, so you have to know your concepts very well. You want to use a barometer, you need to look at this height from this mercury level to the basin mercury level. This distance is your atmospheric pressure. So even for a fat tube like this, right, this to this, right, this is the atmospheric pressure for this one here. And then for this one, even if the tube is slanted, the level inside to the level outside, the distance, that's the atmospheric pressure. So you see, right, they ask you which one has the same atmospheric pressure, 2 and 3 have the same. In fact, I want you to tell me, what's up with 1? What is 1 experiencing? There you go, right? It's a greater atmospheric pressure. Okay? So you got tricked. I don't know why you got tricked. You somehow at some point, I think you know this one. Okay, 10, need or not? 10? Fuyo, 10. 10 wow, 10 is quite interesting also. 10. 10 you got it right. 10 you got it right. 10 you put C, you got it right? Huh? No leh, C is not the correct answer leh. Sorry, false. Yeah, false. Yeah, okay. Yeah, C is false. Because it cannot be increasing one, right? Yeah, it's constant speed. Kinetic energy is not correct. Okay, sorry. I was like, hey, I thought what? Thanks, equal. Okay, 11. Okay. You know. Okay, so I can see that you did some corrections. Okay, I can see that you're trying this question. You did some random working here. Like I think right, the one key thing that I see here. You see, I love to do analysis, forensic analysis. This is me spotting clues as to how a student would do, why the student has made mistakes. Okay, right? You see, I see this whole question here, right? This whole question here. Of all the things that you should have done, you should have underlined this word. Like that's the key thing to find out. Like that's the most crucial thing inside this question, efficiency. So now the question is, now the thing is this, do you know what efficiency is? Like, is there a proper definition for efficiency? Useful over total. Okay, so I hear you say useful over total. That's fine. But then now I'm also a bit concerned. If you know that, why is it not written down? These are corrections, I believe. Yeah, no, you should be writing it down. You should be writing, do you know that writing it down is not trying to give you more work? Making you write it down, I'm trying to make you use less brain power. Because if you don't write it down, you're storing it all in your prefrontal part here, right? You're just like trying to juggle many balls. Write it down. Efficiency equals to useful over total. Right? Useful output over total input. Like write it down. Efficiency is equals to useful output over total input. But then if you know this, the problem will be, so what's considered as useful, what's considered as as useless or something. Okay? Right. Okay. So this question also has its flaws, huh? Okay. So if this worker is pulling this mess up, what will be considered as useful energy? Okay, I tell you this, huh? Work energy power, right? You know this chapter, right? Work energy power. Correct? For these kind of questions, right? There's only 4 kinds of energy that you need to think of. 4 kinds only. Okay? I list out for you the 4, you write it down. I say but you write. Okay? Only 4 kinds. Number 1 is GPE. Does this box gain GPE? Number 2 is KE. Does the box gain KE? Okay? These are the 2 kinds of energies that you need to know, right, for the box. Number 3 is work done by a force. So who's the one doing the work? The worker is doing the work, right? Look at it. He tried to drop you some clues. A worker. He's doing work. He's pulling this 18 newtons, force times this distance, right? Work done by applied force. That's number 3. Okay, number 3. Number 4. Number 4, the fourth type of energy that you need to care about for this kind of question is work done against friction, right? You need to figure out what's the work done against friction. Now, so there's only these 4. There's no other types of energy. There's no spiritual energy, no nuclear energy here also, no internal energy. I mean, internal energy is just heat and sound. Heat and sound is due to work done against friction. There's only these 4 main things, okay? 4 main things. Okay, so the thing is this. The work done by the worker, 18 times 5. Do you agree 18 times 5? Work done is force times distance. Bruh. Work done is force times distance. Do you agree with this? Work done by the worker. How much is that? How much is that? Work done by worker. How much is it? What? 90 joules. Okay? 90 joules. That's the total amount of energy that's being put into it. Like this whole system, right? This box won't move up on its own. So who's supplying the energy? The worker is supplying. How much is he supplying? 90 joules. So efficiency, right? You talk about useful output, you divide it by 90 joules. Because that's the amount of energy that's being put into the system. If the worker don't pull, there is nothing to talk about. There is no efficiency. The efficiency is just zero, got nothing. So the fact of the matter, the worker is pulling, he's putting energy into the system. 18 times 5, 90 joules of energy. Total in. That's the total in. So what's the useful out? So what's considered as useful for this box? Hello, the height it gains I'm talking about energy. I just pointed out to you 4 energies. 4 energies. I already covered the 4th one already, which is work done by the worker. GPE is the useful. Okay. How about KE? How about KE? Will KE be your useful energy? Why is it not here? Okay, so let me tell you this. This question is flawed. Why? Because technically speaking, if you pull this mass and you help it gain GPE and you pull it with increasing speed, which means that you help the box gain KE, then technically speaking, the useful output is GPE plus KE. However, we have no information on time or the speed of the box. Okay, so we have to assume that KE was not gained. That means there was no information of KE. The question is flawed because the teacher should have written, right, pull the mass up over a distance of 5 meters at constant speed. He should have said that. This question is flawed because he should have said that, so that we know that there's no increase in KE. So there's no gain in KE. So the useful output is only the GPE. So you take the GPE, you divide it by 90, that's the efficiency of the system. How much is the GPE? Hmm? Tell me the answer lah. You waiting for me to calculate for you ah? What? 60. 60 joules. Correct? So GPE gain is only 60 joules. Input by the worker is 90 joules. So the efficiency is 60 divided by 90. So my question now is this. Hey, hang on. If the worker spend 90 joules to pull the box up, then the box only gains 60 joules. There is no change in KE. The change in KE is 0. Then what happened to the missing 30 joules? Go where? Correct, work done against friction. But we don't put it in here because work done against friction produces what? Which is not a useful energy for the box. Okay? How about this? Can you tell me how much friction is there? I give you another challenging question. Can you tell me how much was the friction? Any answer? No, friction is a force. Friction must be quoted in newtons. So 30 joules is the work done against friction, which means that 30 joules is friction times distance. As you pull the box up 5 meters, right, along the slope, the friction acts for the whole 5 meters. So 30 equals to friction times 5 meters. You can find the friction. How much is it? 6 newtons. You understand this? This is if they want you to find friction, but they didn't. They just want you to find efficiency only. Are we clear on this? When I do revision for work energy power, I'll be going through a lot of these kind of questions. Okay, next one. What's the next one? Why would you even suggest this? Why would you say that it's not a clean method of producing energy? It's not, yeah. It's like they gave you a free mark there. Hmm. Okay, next one. What's the next one you want me to go through? Okay, so this chapter is called kinetic particle theory. All right, it's this part in my notes. It's the same thing as yesterday's class, right? The ACSIP guys, they also have the same problem with this chapter. They also always think that this chapter is something that they know how to do, and therefore they don't really bother revising. It's the same thing, right? Why? Because you do this in chemistry also. Okay, this is the one. I was just on this page the other day. Here, okay? You have to describe how a gas exerts a pressure inside a container. Molecules move in continuous random motion. They collide with the walls. They exert a force. The force, the total force, depends on force of each collision and the frequency of collisions, like how frequent the particles are colliding. Are we okay on this? Okay. When I do revision, this will be part of it as well, because obviously a lot of students underestimate the importance of this chapter, right? Even in an MCQ, right, you will see yourself lose marks from a question like this. Okay, the volume is slowly increased. That means you let it expand, but the temperature is constant. What's the point of telling us that the temperature is constant? The temperature is constant means the Ke of particles is constant. The Ke of the particles is constant, which means that the speed of the particle is constant. But hang on, that means that if I had a box of gas like that at first, and I went to expand it, like this, I make it a bigger box. Okay, I went to expand it. But the particles now, right, are further apart, they are further away from the walls, but is the speed the same? Is the speed the same as before? Yeah, the speed is the same as before. So here's the thing, look at the options. The option talks about pressure, 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 pressure. It's all about pressure. So one more time, the force exerted, the force over area is pressure, okay? And the total force depends on force of each collision and frequency of collisions. Now, the particle, when it hit the wall, okay, the force of each collision depends on how fast the particle is moving. If the particle moves fast, the force of each collision is large. If the particle moves slow, then the force is less. But according to that question, according to this question, the particle speed is the same as before. So the force of each collision, the force exerted by each collision, is the same as before. However, because the box is now bigger, what will happen to the frequency of collisions? It will be less because the walls are now further, so the particles must take longer. Then they must travel further, then they can hit. So based on this combination of understanding, right, like I said, right, O level is all 2 layers, 2 layers, 2 layers, right? You look at this. Looks like B's answer. Yeah. Gas pressure decreases because gas particles will collide less frequently with the walls, but the force of each collision is still the same. Okay, that's for 13. Let's go on to 14. 14. 14. Do I need to do 14? 14, okay. Which one of the following is not a characteristic of thermal radiation? Oh, C is not right. Hey, how come this paper got so many false answers one? Rate of energy is independent. It's not independent. It's dependent on the surface area. Okay, 15, 16. Oh, 16. Wait. Something is wrong here. Hey, this question is a bit wrong. No, as in the potential energy should be unchanged. Because haven't changed state yet. It has not reached the boiling point. Can I get you guys to clarify with the teacher on this? Cause this one here, I want to hear what's the rationale behind why they say the potential is increasing. It's like if it hasn't changed state, the potential energy should be constant. Unless the teacher is saying that, oh, when it's hot, the more liquid vaporizes. But it's not very usual for this. You guys and those watching the recording, yeah, go and find out from a teacher about this one. I think is there something wrong with this question? I don't know. 17 okay, 18? 18 also can. 19? Waves can. All your waves okay. Is that right? Huh? EM waves also can. Light. Yeah, that one is just angles, right? This one? You don't know what? Yo, it is sign big or sign small, Correct, Then you have to use speed already, what? Okay. May I ask you this, You gotta have some MCQ strategies also, okay? And in a way also, I hope you have faith in my teachings, You know what I'm saying? Like I hope you can trust me enough to understand that whatever I'm teaching you is not some gibberish crap, okay? Right? It's like I've done this many years already, so you don't have to doubt that, my whatever I say is maybe sometimes correct or sometimes wrong one, right? I'm pretty sure I'm quite right all the time for especially for O-level stuff. You already said yourself that you know that it's sine big over sine small, correct? And you wrote down sine p over sine r, but the options was not available. if you had truly trusted the things I teach, and you would realize that shit, there is no option for sine P over sine R, that means that it cannot be A or B. It would definitely have to be something else. You get what I'm trying to say? Because if you have absolute trust that whatever I'm teaching is not gibberish, sine big over sine small is true, then you should have absolute trust that since it's not one of the options, it cannot be either A or B. Like you had to choose C or D. But okay, I understand. Sometimes trust must be built over time. Okay, the question is how long you want to take. Do I need to do this? This one don't need. This one just straight up A only. Right? This one is just memorizing, right? I told you already. This one is just memorizing. You see, enlarged virtual image. There's only one only, which is magnifying glass. Magnifying glass means object is closer to the lens than the focal point. Focal point is 15, right? Focal length is 15, so it must be A. 12. That's the only way, right? 25, okay? So your MCQ, where are most of the mistakes? At the front. There, this one, no? This is the one, no? This is the most common mistake that I always see. The moment you see Earth only, I think I can even show you the video recording of me saying that. A lot of students would just think that, oh, Earth means neutral. Yeah. Do you understand why this is wrong already? Like, I mean, you can understand it. You can write down the correct answer. But are there drawings on your paper, you showing that, oh, the rod is the external influence, attracts electrons. So there's actually more electrons now. I mean, what happens if it was just a sphere and the rod, like that? Then you will have one side electrons, the other side positive charges. Then when you earth it, extra electrons will go in and fill up the spaces. So it will just go in like, neutralize the positive side. Okay? But then you have excess electrons because no matter what, this positive rod is still attracting electrons. So there's like an excess of electrons being stored inside this sphere here now. D is a option. D should be one of those options where you spot it already. You should know that, oh, the teacher is trying to trick me into putting D. I should not put D. Like I would do anything rather than to put D because it cannot be D. Part of the reason why I suspect some students when they do this type of question is they think, oh, neutral because you never draw anything in the sphere. So that's why I thought it's neutral. Yeah lah, then you deserve to lose a mark lah. Right? Because if you expect everything to be given to you, then you will definitely lose a mark. Oh, this one's a good one. Damn, I didn't go through this one. 27 is an electroscope. Dang it. So they went through electroscope. Okay. Maybe I'll do electroscope next time. 28 is what? Do I need to do this? 29, do I need to do 29? Do I need to do 29? So you could calculate this. I hope so though. 30? Do I need to do 30? I need to do 30. So you did write down the equation. R equals to rho L over A. Now, is your MCQ paper the same timing as your paper 2 or they gave you separately? They gave together. So in a way, maybe you're running out of time. I don't know. So when you're given this kind of question, a resistor and then a second resistor, Then you just write R1 equals to rho L over A. R2 equals to R2 is 3R. 3 times of R1. Same material, so it's the same row. But then the cross-sectional area is A over 4. So the question is, what's L2? Correct or not? Okay. So when you do this kind of question, it's not that you don't know what's R rho L over A. You wrote it correctly. The reason why you don't know how to do, actually you almost got it. What? But why is there a 4 up here? Oh, you went to bring the 4 up there. You went to bring the 4 up already, is it? So you did not sub this into here. That was the step that you're missing. So if you sub it in, it will be 3 times rho L over A equals to 4 rho X over A. You can start cancelling off stuff. 3L equals to 4X. X is equals to 3 over 4L. That's the answer. So you're just missing one step. So it's not that you don't know the equation, you know the equation, but you don't know how to do the manipulation. This is not physics. This one is formula manipulation. Okay, we go on to structure now. Have you done corrections for this? I don't see no light blue. Yeah. Huh, what? Uh-huh. Okay. You see this thing here? What's this? Is this right or wrong? This is wrong, huh? A equals to V minus U over T. I don't care if U is 0. If you want to write equation, you write the proper one. A equals to V minus U over T. Understand? Where do you get 18? Oh gosh. You went to find the value at the you went to find the value at the 40 and then you took that value and divided by that number, is it? No. You're supposed to find the whole gradient here. So I don't know whether I mean this is math, right? The gradient of this entire line, do you understand that it's the same gradient as this small little triangle here, as this medium-sized triangle here, as the entire triangle there? It's the same gradient throughout, right? Okay. Then they ask you to calculate the average velocity of the car. Oh, this is a trick question. This is a trick question, guys. What's the average velocity? As in, can you give me the definition of average velocity? Do you see why this is a trick question? This is so tricky. Ralph, tell me what's average velocity. Or give me the definition of velocity. What is the definition of velocity, man? Hello? Definition of velocity. Don't know, say don't know. I don't want to stand here waiting for you trying to think. Rate of change of displacement. Don't know already, I say already, write it down. So they're asking what's the average velocity, meaning they want you to find what's the average rate of change of displacement. Right? Then they're asking for the entire duration. So what you need to do is you need to go and find out what's the total displacement over total time. So if you look at this picture, how do you find total displacement? How do you find total displacement? Find the area of this big triangle. Do you see that this area is positive area? That means that this area here is positive displacement. Then you go and find the triangle at the bottom here. This area here is negative displacement. So total displacement is equals to the orange area minus away the blue area. Do you understand this so far? Then after you found the displacement already, total displacement already, divide it by total time. Total time is how long? 150 seconds. So they took this whole thing, you divide by 150 seconds, you will find your average velocity here. Curveball. What if they ask you to find average speed? Give me the definition of average speed. Total distance over total time. So if they ask you for average speed, right? Let's say they ask you for average speed. It will be total distance over total time. How would you have find it? It will be the orange area plus the blue area. Then divided by 150 seconds. Do you understand the difference between the two? Okay. So they ask you to draw the speed time graph for the car during the entire duration. You've already been given a velocity time graph. Your job is to convert it to a speed time graph. What's the difference between velocity time and speed time? What's the difference between velocity and speed? Okay, no. Velocity is a vector, speed is a scalar. That means for speed, we don't care whether it's going negative or not. For velocity, velocity has positive velocity and then negative velocity. For speed, I just care about the absolute values. So you want to draw a speed time graph, the speed time graph will basically look like crossing at 130. Where? 130, then two boxes. This is how many? This is four boxes. I just zoom out a bit, sorry. So you want me to draw a speed time graph, the speed time graph will look like this. Okay? I will just mirror the same thing, right? Straight line, and up. That's how a speed time graph looks like. Are we okay on this? Who was that? No. What? That was a girl's voice. Holy shit. There's a ghost in the system. Okay. What's this? This is pressure. This thing here is a hydraulic system. Okay? Alright. So the way I see your calculation here, also like not there. Right? So I'll tell you this. It's the same thing for yesterday's class. A bunch of them also don't know what's going on here. Like no idea. Like, oh, I don't even know what this is all about. Okay? Which means that I have to revise this. Right? I have to do the revision for this. Now let me tell you this. I just started teaching this to my year 3 class. My year 3 class is on Saturdays 1:30. I don't need you to be there at on Zoom or to be physical, doesn't matter, right? But I'm offering you, right, to learn it through either video or online if you can make it. Okay? All you have to do is just to take the initiative and ask me for the recording for this. Because this one obviously is you have no idea what's going on. This thing is like like not there one. Okay? Yeah. So like pushing piston through some distance, significantly greater force must be exerted to explain why this is the case. Right? So this thing here, like the calculations here is obviously, and if I go through this one, right, I'm like teaching you the whole like what call it, the whole concept here, right? Which is gonna be like, whoa, it's gonna take damn long. So you take the initiative, you ask me for the video on hydraulic press. I'll send it to you, you learn. Okay? Alright, then the next one is this one. Same problem with them. They like this not the exact same question, but you know, they also have similar type. You have it worse. They purposely go and give you weird units some more, but actually it's all in grams, so it's so not so bad. So your definition, you lose marks from definition. This one here is 3 marks, right? Gone. As it goes from 60 to 0, what's going on here? Like what's the matter here? Like I don't know what you don't know here. You don't know what you don't know. As in like, are you saying that you don't know what you don't know because you use the correct equation to get this number? So you have never. So you don't know Q equals MC delta T. Okay. Then do you understand the? Do you understand the Q equals ML equation as well? Okay. So for this heat capacity as well as that pressure, right? These kind of things we identify as a severe knowledge gap, right? It's like malnutrition. You lack vitamin D or vitamin A. You need to eat more carrots, right? So that's a knowledge gap, right? It wasn't a mistake on your part, right? In the sense that you made a mistake. It's a complete kosong, a complete gap, and you need to fill up that gap. And to fill up the gap, you need to go through the lesson. But obviously, if I were to teach you now, this paper review will end up being 2 weeks, right? Because all these things take time. I can create the time for you. You ask me for Q equals MC delta T, Q equals ML. But even after you watched it already, maybe you still have to come back here and then you may have to learn how to apply the equations, especially for part 2. But I can't do this now if you haven't even figured this one out because this is a major gap. Yes, Ikwang. Okay, can. Okay, bye. So there's no way for me to go through this in total now. Do you understand? So if you have to ask me for the recording for this, you take the initiative, you ask me for this, and then for part 2, after you watch already, I'm pretty sure you still might not know how to do part 2. I will guide you through, but I cannot guide you through if you don't even know what these equations are. Right? There's no way one. There's no way for me to say like, oh yeah, you do this, you do that. Then okay lah, you get the answer. No way, man. You need to attend you need to sit down for the lesson. That's gonna take 1 hour for you to learn this. Okay? But you know what? Grand scheme of things is only just 1 hour. We just went to define electric field the other day. So this is something that I went through with you. This is something that I went through with you. Okay? What's this? Like, why would you write thermistor? Did you forget? Or what? Because this one is not a knowledge gap, because this one I went through. I showed you the graph before. We talked about this graph before. You sat in for those lessons before. So this one is what? You forgot? Or what? As in, why do you write thermistor for this one? I'm gonna ask you this, okay? If I ask you to take out your notes and flip to the page where you can find this graph, will you be able to find it from my notes? Yeah, you will, right? Okay, so I'm going to leave this to you. Because if I tell you now, like, you already know the answer, maybe, right? But it's definitely like something that is within your control, right? Yeah, it's within your control. Okay. You see that over there? You see this right here? Yeah. This one here is, I don't know what to say though. This one is, this wrong. Like, you wrote the wrong equation. So this is not a knowledge gap. You know that it looks somewhat like this, but you remembered it wrongly. So you need to spend some effort into memorizing some things. This is memory work. This equation is also memory work. Right? So memorizing is not just sitting there and just like, oh, I'll just look at the equation and memorize. Sometimes it comes with practice. So you may have to spend a bit more time practicing. So I'm going to leave that to you because I believe if you know that that's wrong, you know how to fix it. If you need to ask me for the Ohm's law, right? That part of the video again, because I also went through this one. Like, what happens to resistance X, right? As PD across the increases. I went through exactly that. Like that whatever the X is and whatever happens to the resistance, it might be even written in my notes. If you look at the page, it might, like, if you're looking at the page right now, the page actually might even tell you exactly what the answer is. So this is within your control. I'm not going to tell you the answer. You have to go and do your own corrections. Fix it. So do you see a recurring problem of memorizing the equations wrongly? Do you see that? So the question now is it panic? How do you resolve panic? You have to be confident. How do you gain confidence? You have to practice. You cannot possibly imagine that you come to my class once a week. You sit there, you look at me, write stuff on the board, and then you tell yourself, I will be able to remember this. There's absolutely no way. You have to go and do the schoolwork. You have to go and do the extra practices if you're not doing your schoolwork. And you have to be asking me questions. I've not gotten questions from you at all. Do you understand? Like, if we look at our group chat, I mean, if we look at our personal chat, okay? I think since March, I think since March, I have gotten not many questions from you, right? Even March, right? Since March, now it's already May already. So this is a lack of practice. This one here, lack of practice. There is, you see, right? A mistake is made from what? A mistake is made from. Okay, this is a mistake. This is not a knowledge gap. You obviously can write some Q, can write some T, can write some V. It's not like the other two cases where you completely kosong. So a mistake is, it comes from not being familiar. Why are you not familiar? You're not familiar because you didn't practice. You have to practice. So the LDR, you got it right, I hope. State what is meant by potential divider. A potential divider is basically a circuit where the potential is split between two components in series. Okay? So yeah, I didn't define this. I know this, right? I know I didn't go through this in class. This is on me, right? This 1 mark is on me. A potential divider is a circuit where two resistors in series, right, shares voltage, right? Or you can say that voltage is shared between two resistors in series, shared proportionally. Sorry, how does what work? This one? You want me to show you? Are you sure? I'll show it to you, okay? Cause I think you might be shocked by it, you know. Can you tell me what's the voltage across each of them? 4 volts, is it? 2 volts, is it? Potential divider. This is a potential divider. You have divided the potential. You have shared the voltage. That's what a potential divider is. Lame, right? It's damn lame. I know. It's damn lame. Huh? You mean like that? Yeah, it is. It's not complicated. It really isn't. Look at the math we've been doing so far. Which of it remotely looks like differentiation or integration or EPGP or anything like that? None. It's all plus minus times divide. It's not complicated. Stop believing that it is. Right? If you had just sat down to look at the definition list and memorized it, a lot of things will come to you naturally. But because you avoid the commitment, right? We talked about this before. We know that you're avoiding the commitment. Okay, we can do the math for this one. 6 volts, 1000 ohms, right? LDR is there, right? Okay. Then what did they say? In a brightly lit room, the PD between X and Y is 1.6 volts. Where's X, where's Y? So they're saying that when it's bright, is it? When it's bright, they're saying that the voltmeter reading here is how much? 1.6 volts. Is that right? So how many volts is this guy? 4.4 volts. 4.4 volts. Okay, I don't know what's the question. What's the question asking for? Calculate the resistance of the LDR. So you tried using the ratio method. And you did this part correct. but then somehow your ratio method didn't work out. Right? What happened? What is it that 1000, 4.4, 1.6, and what ohms is this? Like this ratio method, you're trying to use a ratio method. I get that. But why didn't a ratio method work out for you? Higher resistance, more voltage. This one less voltage, so it should be lesser resistance, but you end up having 2750. So obviously you did one of the ratios wrong. You understand? And second time, you wrote the equation wrong as well. You see, right? You memorized the equation wrongly. It's like a lifetime of pain. Because the worst part now is you may have to even spend some effort unlearning that. You may have to erase that from your head. Now you have like sometimes the next question you do next time from now on, right? You have to go and check yourself. You have to check your self-doubt. Was it this or was it that? Just one simple equation. This equation caused you all the problems. This one you got the 2 marks, that's good. This ratio thing, I leave it to you because I'm pretty sure you know how to do ratios. Right? Your method is correct, but you obviously did not do the ratio correctly. Period is time taken, not how long. How long can mean length? Long ma, how long? Time taken for one complete cycle. Determine the period. Period is correct. Yeah. So you get that? Do you know what's going on here? From your MCQ, your waves was okay. I actually believe that at this point you're panicking already. You're just writing gibberish. Somewhere, somehow, you spend too much time, and towards the end of the paper, you're already writing gibberish. Anyway, what's that supposed to be? So you wrote something. I mean you wrote something. But what were you trying to write? No, I know we always, I mean sometimes at some point we like to joke that, oh, the wavelength symbol looks like the Chinese character, right? Like this Chinese character Ru lah, right? But since when did the Chinese character become Ji? A bit different lah, slight different, but I mean I can understand why it looks the same, but yeah. But even after you write this, right, you were not able to do anything. You also have this weird habit of trying to force an answer onto the thing without, like you're so focused on trying to give an answer, but you're not even like your concern is you don't understand this. Maybe you don't understand this. I do this kind of forensics all the time. Like I analyze how people put their answers down, and I judge. I am judging, okay, your actions for this. Like you're very, very concerned about like, oh, must put an answer down, must put an answer down. But what's the point? You're not gonna get anything correct. Why don't you spend the effort trying to recall these things? Like you almost got it right. V equals to F lambda. Like V is speed, F is frequency, lambda is wavelength. You want me to find wavelength? This is the equation. So maybe you could have written this. If you had known that that was the wavelength, maybe you could have written, instead of writing this thing, I would have rather you write this. Then maybe you could have written V knowing that the speed is 20 cm per second. maybe you convert it to meters per second, 20 meters per second, but then maybe you get stuck at F. Okay, right? I mean, if you can write up to this point and you don't know what F is, at least, you know, as a if let's say you call me a professional coach or professional like if I analyze someone's workings, right? I mean, I analyze this. We can do up to here and you tell me you don't know how to do frequency. I'm at least, okay, never mind, don't worry, Ralph. I'll teach you how to find frequency. But you write this down and then you try to force an answer out like you know, you just like, yeah, just come on, answer. Let's just get it over and done with, right? It shows the immaturity lah. Okay? So you need to find this frequency, but you need to know that there's a period here. So you need to draw the link between the two things. Like I said, O levels, everything is two layers. So there's a frequency is equals to 1 over t, which I think I saw you right just now. But it's okay, maybe I remember wrongly. So you got the period. If you sub in the period at the bottom here, you could have gotten the F. If you put in the F here like this, so 1 over 0.6, that will be your answer. Can? Okay, let's look at the next one. By this stage, right? You see this here? By this stage, how many definition questions have they been asking already? Yeah. Plus the fact that a lot of other things above, right, depends on your understanding of the definition as well. What's this? Where's P? Wave P, is it? Is this wave P? Is that wave P? That was wave P, is it? Okay, hang on now. What do they want? Sketch for the displacement distance graph for one complete cycle of wave P when t goes to 0. Do include the necessary values. So basically they want displacement distance, right? I mean, I'm also a bit like, you know, the style. I'm very sure everyone in your life would have mentioned this to you many times. When you're doing the question, underline the keywords, right? Like when you're doing the question, like, you know, I can see you putting effort here, you know, but you're not putting effort into reading the question. Like you're not underlining it. I don't know. I don't know. It just tells me a lot about the habits, right? Okay. Anyway, displacement distance graph. You have no idea what this is it? Okay. Okay. I mean, have you joined when I was doing waves? So I've done this before. As in, I've covered with you this one before. It's in the notes. Displacement distance followed by displacement time. And I said that for every wave, you need to do graphs. What can you find from a displacement time graph? What can you find from a displacement distance graph? Right, that sort of thing. Okay? So, kind of a bit weird for you to say that you don't exactly know what a displacement distance graph is. So if you need a refresher, by now I already forget what you need. So you keep a list, ask me for it. Cause I don't think it's I mean it's like I'm recording this session, obviously. I can go and dig out from the recording and then say, oh, Ralph needs this, Ralph needs that, Ralph needs this. But I'm gonna tell you this, okay? I refuse to do that. Because you have to take the initiative. Yeah. I'm not in the business of mollycoddling or babysitting. So if you have to go and ask me for things that you forgot, you ask me for the things that you forgot. Right? I'll leave it to you to, I don't know, if you want to show your interest in learning, because the resources are all available to you. So if you're like, oh, I need to get this right. I need to remember how to do displacement distance graphs. By all means, ask me for it. Because it's something that I've done before. So this is a displacement time graph, right? The very start, they gave you a displacement time graph, right? It's a displacement time graph. They want you to convert it to a displacement distance graph. What they actually mean is that they just want you to draw a graph that shows, right, from time equals to 0, right? So when time equals to 0, the displacement of P is 0. So we start off by this one. And then they want you to draw one complete cycle. So only just one wave, up, down like that. Okay? They want you to indicate this is the amplitude, and they want you to indicate this is the wavelength. That's it. That's how many marks? 4 marks. Because that's exactly what happens when you yeah. So I'm telling you that this is the answer. You have to go and figure out all the answers lah. The workings are the amplitude you write 3 mm, so it's 3 mm. The lambda is the wavelength that you should have calculated from here, but obviously you didn't calculate the wavelength. So if you put a lambda here, at least not so bad. You label the axis here, this is displacement, and you label the axis here, this is distance. Okay, displacement and distance. And this was the one of two most important graphs that I said that when you are doing waves, you have to learn, which is exactly here. Displacement, distance, or you can write it as position, right? This here is the amplitude, right? That's the amplitude over here. This is the amplitude, which you can indicate on the axis here, and that's the wavelength, right? Because displacement distance gives you wavelength. Displacement time gives you period. Yeah, that's pretty much it. So this is a good 4 marks all gone. Yeah. Hmm. I will offer you vector diagram drawing, the videos. If you want, you can ask for it. Because I know I didn't go through this before your test. What? I mean, am I going to blame you for getting losing all the marks here? I'm not going to blame you, dude. Right? You see, there's a difference. If I know I've gone through something before with you, and you made a mess of it, I'll be hard on you. But this one, I know. I didn't go through with you before. Vector diagram. Vector diagram takes one full lesson. And I know I didn't manage to chase this up before your test. I'm not gonna, but I leave it to you to ask for it. Okay? Yeah. What you want me to give you a 5-minute miracle to help you understand this whole thing? There's no way. You can like, oh, please 5 minute 5 minute. No. If I can do that in 5 minutes, right, then every single student in the whole of Singapore can do all these kind of things. Now 5 minutes 5 minutes, everyone will get A1 already. These things take time. These things are difficult. If it was easy, every mother would do it. Right? Everyone can do it. There will be no more N levels, there will be no more poly, there will be no more ITE. You get what I'm saying? These things are difficult. But the difference is you have the resource. I will gladly give you the resource. But you have to go and sit down and learn. There's no such thing as a 5-minute lesson. 5 minutes, right? Crash course, whole of physics, right? You will learn everything in 5 minutes. Who's gonna lie to you? I'm not gonna lie to you. So if you have to go and ask me for the recording for this, go and ask me. Then after you watch the recording, really, you still don't understand, then by all means, sure, we will sit down and we'll talk about this question. But this one I didn't go through with you, so I don't blame you. Okay? Wow, the rest of this question is all riding on that, is it? No more time already lah. Wow, chunky 4 marks here, then this one here 2 marks here. Must be added to the to keep the mesh stationary. Hey, this B part 1 is not fair. Are they asking for the acceleration of the block down the slope? Did they ask for the acceleration of this block down the slope? Hmm. Oh, it's just this string lah. Like you needed, that means you needed to use this diagram to find out the tension T. Then when the T breaks, then the resultant force is the downwards, which is the tension itself. But that means if you couldn't do this first 4 marks, right, you would not ever be able to get this one also. These 2 marks here. So I can't go through this now because this will require you to understand how to draw the whole vector diagrams. And after you draw the vector diagram ready, then you can start working on like how much mass you need to balance the thing, what's the acceleration here, right? This one here I think still can. Did you try to draw this line or what? Was this line yours? Hmm. These last 2 marks here, these are very extra. I think I'm more concerned about like you being able to get the acceleration. But in order to get the acceleration, you need to know how to draw the vector diagram. So I leave it to you. I can't go through this now because if I go through this now, you will be just hearing me talk gibberish. Because I'll just give you the answer, but you can just read that off the answer key. Looking at the answer key doesn't mean anything. Like if you don't understand the concept, you look at answer key also no point on. Because down here is the obvious knowledge gap. Like this is the obvious knowledge gap. You get what I'm saying? So you have to watch the video first. Okay, you kept the entire list of what you need to catch up on already? Yeah. Then you better ask me for it. That means I have to come back to this paper again. I can't do this now. Like you I can't do this now because you have gaps, right? You need to patch up the gaps first, then I come here and then I can tell you that from the lesson I was teaching, this is how you do this question. Otherwise I'll be going through like all the chapters with you right here right now. That will take another like 5-6 hours. There's no way lah. Okay, I am done here. Do you have any like particular things that you want to clarify with me? What file? What are you talking about? Have you sent the request? But you're requesting this access for what? Uh-huh. What else? I mean, the other stuff is the videos. If you want the videos, you have to ask me. The videos are not inside there. Okay. Okay. Yeah. Yeah, like, it's hard for me to it's difficult for me to go through any of these questions in detail now because I know you haven't been instructed on this before. So there's no way for me to go through this now. You have to ask me. I also did the same thing for the IP guys also. Yesterday also some of them don't know how to draw vector diagram as well. So I also told them you have to ask me for the recording for how to draw vector diagram. Like otherwise I can't possibly go through every, like like it's not about me going through the question, no. It's about me teaching you the concept. Like, and teaching you the concept is going to be like this vector diagram is going to take half an hour. That hydraulic press is going to take another half hour. The thermal thing is going like easily the whole thing will become a 5-6 hours thing already. I got the resource. I got the videos. I can send it to you. There's no. It's not like your question is question specific. It's not like you don't know how to do like or maybe you made a mistake in one of the small things here and all that. No, it's a blanket got blank got kosong knowledge inside. So you have to go and patch up your knowledge gaps. Okay, I leave it to you to request because I really cannot keep track of what you need and all that already. I mean right now right here I know you need vector diagrams, but there was what hydraulic press and thermal properties and all that. You have to ask that from me. I have to go home already, otherwise my cab ride is gonna be damn expensive. Cause I'm still at the center. Yeah, you are comfortable at home, but I need to go home and I need to eat dinner. I haven't eaten my dinner yet. Okay, all right. See you.